Alright, in this section we're still going to continue with differentiation, and there are going to be several rules that we're going to look at in this section on how to find a derivative. These rules will be things that you can use instead of having to use the limit definition that we had in the previous section. It's actually going to make it a lot quicker, a lot simpler, because yes, the limit definition does take time, but you've got to understand where a derivative comes from and exactly what it is. And that requires having to take the time to do the previous section, even though that is the long, hard way to do a derivative. Alright, so the first rule that you see here, textbook refers to it as Theorem 2.2. It's called the constant rule. And if you remember, this is a notation that can be used to indicate derivatives. So this is just telling you to take the derivative of this function. Now, C is just representing a number, so that's why they call it the constant rule. So this could be, what is the derivative of 5, or what is the derivative of -1/2. The derivative of a constant is always just going to be 0. Now don't get that confused with a limit, because the limit of a constant is the constant, but the derivative of a constant is going to be 0. Okay, next rule is referred to as your power rule. So in this case, you're asked to take the derivative of x to some power. So this could be x to the third power, x to the fourth power. So what you're going to do with your power rule, of course, n is your exponent. So you're going to take whatever your exponent is, and you're going to bring it and put it in front of your variable. And then you're going to do that power minus 1, which means your exponent is going to decrease by 1 when you use this power rule. Okay, so the two problems that you're seeing here are going to be examples of the constant rule and of this power rule that we just talked about. So make sure when you start your derivative that you do use the notation that indicates derivative that we talked about before. So I'm going to use y prime. Now just representing or just recognizing that this is a constant. As I told you, the constant rule tells you the derivative of a constant is just going to be 0. So there's no work that you have to do to prove this. This is just knowing that rule. Okay, this is going to end up being your power rule. Okay, so your power rule says you take your power, bring it in front of your variable, so that means you're going to multiply it, but then you have to do your power minus 1, which just again means that your power decreases by 1, therefore that will be to the third power. So this is the derivative of this. Now, I mean, if you imagine having to use that limit definition with this, you'd have an x plus delta x to the fourth power that you would end up having to work out. So, and that would take you several minutes. So definitely this is a lot quicker. Okay, next. Alright, the problems we're going to look at over these two is actually going to be power rule, but the way that they're written, it does not look like the problem we just finished that we used the power rule on. Sometimes you have to rewrite the problem in order to be able to use a certain derivative. And in this case, what you would want to do is rewrite this as x to the 1/3 power. Remember, you can always rewrite a radical with a fractional power. Of course, the x is understood to be to the first power, so that's where the 1 comes from. So now you do have x to a power, and you can use your power rule. So you take your power, bring it to the front, and then you have to decrease your power by 1. So you would have to do 1/3 minus 1, which is going to give you a -2/3. Now you will need to rewrite this answer just because of the negative exponent. Rewrite it so that it's positive. So you would have 1/3x to the +2/3. So you would need to take that and bring it to your denominator. Okay, on number 4. Now, you do have your variable to a power here, but it's in your denominator. To use that power rule, then your problem can only be x to a power. Of course, you can use whatever variable you want to, so it doesn't always have to be an x, but it needs to be just that variable to a power. So this one you would need to rewrite as x to the negative 5th power. So bring it from the bottom to the top, of course, which causes the sign of your exponent to change. But now you have it in a form that you can take your derivative. Okay, so your power is -5, so you bring that to the front, and you decrease your power by 1. So -5 minus 1 gives you -6. And just like the previous problem, you do need to rewrite this so that you have a positive exponent. So that would be -5 divided by x to the 6th power. Okay, here's another rule. Constant multiple rule. So in this case, you're going to have a number multiplied times your function. Now your function may just be a variable, but this would be you having a number in front multiplied. So if all you have is just a number in front multiplied, you actually only take the derivative of the function. So you notice that this has the f prime of x, and then the constant is just still continued to be multiplied times that function. Alright, so this first example, see, my function would be the x to the 3rd power. This is where you're going to use your power rule. So this constant multiple rule just tells me that I'm going to continue to multiply 6 times the derivative of this. Now you can stick to using y prime. I'm just going to do something different here. If you remember, dy dx is also a notation to stand for derivative. So since the 6 is being multiplied, you're just going to do 6 times the derivative of x to the 3rd. So use your power rule on x to the 3rd. So you take your 3, bring it to the front, and you decrease your power by 1. Now you do need to simplify this and go ahead and multiply the 6 times the 3, so you would have 18x squared. And once you see how this rule works, you could easily go, from here straight to your answer. Because when you're using your power rule, if you do have a number in front multiplied, you're always just going to end up doing that power times that number, so which gives you the 18. Okay, still continuing, and my variables here don't match up. Let's just change this to an x. I guess I meant to make them both t's. It doesn't matter. Okay. You do need to rewrite this just a little bit to be able to use one of the rules that we've already been using, and that would be to pull your fraction out front. So you need to look at this as 4/3 times x squared. So now taking my derivative, now this is going to be that constant multiple rule, so this would just be 4/3 times, now apply your power rule to x squared, so that would have to be 2 times x to 1 less power, so that would just drop to a first power. So now go ahead and actually multiply your two constants, so that's going to give you 8/3 x for your derivative. Okay, number 3. Again, there's some rewriting here that we need to do. Of course, you just saw on that previous problem, having to pull the fraction out front. You're still going to want to do the same thing here, so let's go ahead and pull the 2/3 out front. Now, we had a radical a while ago. You saw that I had to rewrite the radical, but you also saw in a different problem where I had a variable to a power on the bottom and I needed to take that to the top. So that's two things we've got to do, and you can do it all in one step if you choose to. I tell you what, let me make this into 2 steps just so I don't lose anybody. Let's go ahead and rewrite this as x to the 1/5. No, I'm sorry. 5/2 because your exponent is your numerator. Of course, this is a square root, so that's where the understood 2 comes from. Okay, now pull the 2/3 out front, but then you're also going to want to take this to the top, which will give you a negative 5/2. Now, I haven't started my derivative. This is all just simply rewriting my problem so that I can take my derivative. So I'm going to use dy dx again to indicate that I'm starting my derivative. So this is your constant multiple rule, so you'll have 2/3 times, and now use your power rule with x to the negative 5/2. So take your power to the front times x to 1 less power. So you've got to do negative 5/2 minus 1. Of course, you can always use your calculator to help you out with that. That's going to give us negative 7/2. Okay, I do need to rewrite this. Of course, here you can say your 2's cancel out and you're left with negative 5/3. But then you do need to bring this to your denominator so that your final answer is written with a positive exponent.